Hello, it's Kyle, and I'm back with another problem. Today, we're going to differentiate the function f of x equals the square root of x minus 1 using the difference quotient. And the difference quotient states as the limit of h approaches 0, as the limit of x plus h minus f of x over h approaches 0. When you find that, that's the derivative. Okay, so first, we get the square root of, and when you plug in, to do this, you plug in x plus h whenever you see an x. So, the square root of x plus h minus 1, all that's under the radical, minus the function, which is the square root of x minus 1 all over h. Get rid of this. And also, I messed up here, but to what you're supposed to write the limit as h approaches 0. Okay, so how can we do this problem? Seems like a rather complex problem. So what we have to do, we have to multiply by the conjugate. So the conjugate, if you learned in earlier math courses, you multiply, it's to get rid of radicals. So you multiply the whole thing by the conjugate, which is x plus h minus 1. Well, I can get rid of that. So x plus h minus 1 plus the square root of x minus 1 all over this same thing. So you're basically only multiplying by 1 over the square root of x plus h minus 1 plus square root of x minus 1. So since you're basically multiplying by 1, that's why it doesn't mess up the problem. Now to do this, you get the limit as h approaches 0. And so we have a difference of squares here. So what we can do, we can square the first term and we can square the last term. So our first term is square root of x plus h minus 1. So if you square both of these, you're just going to get x plus h minus 1. And then, since it's a minus, you have to do minus. And you have to make sure you have this in parentheses, so you have to distribute that negative sign. So the square root of x minus 1 times the square root of x minus 1 is just x minus 1. Okay, so if you distribute this negative, you get minus x. And then you distribute the negative to the 1, you get plus 1. All over h times the square root of x plus h minus 1 plus the square root of x minus 1. Okay, so now let's look. We can cancel out some stuff here in our numerator. So we can cancel, you have a positive x here and a negative x here. So you can cancel these out. And you also have a positive 1 here and a negative 1 here, so you can cancel that out as well. So that leaves us with the limit as h approaches 0 of h all over h times the square root of x plus h minus 1 plus the square root of x minus 1. Wow, what do we have here? We have an h and an h. We can simplify this, and that becomes 1 over the square root of x plus h minus 1 plus the square root of x minus 1. So now, since we have nothing in our, and the reason we did this whole process is because if you had directly input 0 into the denominator, you would get an undefined function. And we don't want an undefined function. So now, I'm going to bring it down a little bit. So to do this problem, you have limit as h approaches 0. And now since we don't have anything that would cause the denominator to become 0 and have an undefined function, we can evaluate this. So 1 over the square root of x plus 0 minus 1 plus the square root of x minus 1. So to further evaluate this, you have the limit as h approaches 0 of 1, well, which equals 1. And you have square root of x minus 1 plus square root of x minus 1. So you have 1 over 2 square root of x minus 1. And this is your answer. Thank you.